Hi, Integrated Math 1. Welcome to our 5.2 study guide. Yay! So this is our review for our Unit 5.2 test which you have coming up. So I've got my study guide here in front of me. Hopefully you've got yours in front of you as well. Keep in mind, you are also going to need a compass, right? You need a compass. You're going to want that. You do need a straight edge and a protractor. In this case, my straight edge is going to double for my protractor. Super convenient, really useful. And of course, please use a pencil so you can erase things, fix them as we go along. So we're going to go ahead and just jump right on into this. Again, you know these problems are going to look just like the ones on the test. Very, very, very similar. So to start things off, number one, we would like to construct a line that is parallel to line M and passes through point A. So we're going to actually make congruent angles, right? That's our deal. If our angles are congruent, our lines are parallel. And I'm going to kind of use a little bit of a cheat. I'm going to draw my transversal through A such that it hits line M. And it can hit here or here or here. However you want to do it is fine. I'm going to do it like this. I'm going to make it way too long. You know this goes. I'm going to make it way too long. So here's my transversal, which I'll call T. I'm making it way too long. And then we're just going to make congruent angles. If you recall from the last unit, I put my stabby side on the vertex, which I have right here. So I'm going to put my stabby guy on the vertex, and if you recall, we swing it such that it hits both sides. So I'm going to make sure it touches both sides. And then I'm going to hop over and put a matching one on point A. That's my new point. Kind of turn my paper. Sometimes it's easier. So now I have a point here and a point here. I've also got one side. I just don't know where the other side of that goes. That's what we're trying to find. So I'm gonna go ahead and take my compass, and this is where I measure how wide my angle is. So I put my stabby side on one side. I'm gonna adjust my pencil so that it touches the other side. I'm having some issues here. My poor little compass has been through a lot. So stabby side on one side, pencil on the other. And then I'm going to hop over and put the stabby guy on that side that I already know. I'm going to go ahead and make a mark with my pencil. I know it's a little pale. Hopefully you can see it okay. And there's the other side. And if I take my straight edge, I can connect those up. It's not going to be perfect, but it's pretty good. Oh, I kind of missed a little bit. That's all right. And now I have parallel lines. Yay! So I'm going to be looking for that transversal line through our point. I'm going to be looking for those congruent angles. So I'm looking for those matching arcs. And I'm looking for this little mark right here that shows me that you measured with your compass and you made a little mark over there. So that's what I'm looking for when I'm looking at this problem. And you just made parallel lines. Good job. Yay. I'm going to come over here. It says draw lines of symmetry for the regular pentagon. So a line of symmetry means that I can fold it along that line to do the butterfly thing, right? I can fold it in order to map one side onto itself, to carry one side onto itself. So I'm going to use my straight edge. And since it's a regular pentagon, I should be able to go from point to the center on the bottom, right? I should be able to be like, woo. And there is a line of symmetry, right? I could fold it perfectly down this line and that side would match that side. But it's not the only one. It's not the only one. There's actually several of them. So there's one here, but I could do it from this point to the center down here, right? Right? I could do it from, you can make them dashed, you can make them solid. I'm not fussy. I can do it from this point to the center on the other side. Oh my goodness. Look at all these lines of symmetry. Oh my gosh. I could do it from this point, vertex, to the midpoint of the other side. Oh my gosh. Oh my gosh. There's like 5 lines. I'm going to redraw this one. There's like 5 lines of symmetry here. Wow. You could fold it on any of those, and the 2 sides would fold right on top of each other. They would be perfect. Oh, I missed one. It's like something's off. This vertex to the middle point of that side. Did you catch that? You probably caught it. You probably saw that I missed that one. Woo! There we go. Wow. Wow. So those are all lines of symmetry. You could pick any one of those lines and you could fold your regular pentagon on it and it would be a perfect reflection on the two sides. That's pretty snazzy. Let's come over to question number 3. This one's trickier, but not impossible. Determine the number of degrees you can rotate the equilateral triangle to carry it onto itself if possible. So remember that in order to have that rotational symmetry, it has to be more than 0 and less than 360 degrees. Because you can take anything and do a full rotation and it's back onto itself, right? So I know that I can do a turn, right? That would work. And another turn, and another turn. 3 turns within that 360. So here's what I'm going to do. I'm going to take my 360 degrees. And since I can do 3 clicks, 1, 2, 3, if I divide that by 3, I don't need a calculator. I can do this without a calculator. That's 120 degrees. So it turns out I can map it onto itself by 120 degrees. But if I do another 120, so 120 degree turn from here to here, if I do another 120 degree turn, I'm now at 240 degrees. And of course, that third one would be 360 degrees. So I can do a couple of these. Ooh, snazzy. Let's go to question number 4. Ooh, this one's trickier, but that's okay. That's okay. We can do this. We can do this. Just draw and describe the sequence of isometries, which shows that the 2 figures in each pair are congruent. Well, if I go from A to A prime, and I can see that B's back here, C's back there, C prime, B prime. So here's my original, here's my new guy. So first of all, it looks like I flipped it up, doesn't it? So I'm gonna point that out first, and this isn't gonna be perfect. It's kind of an estimation, but it looks like I've got a line of reflection, right? Like this. We'll call that line M. Why not? But even then that doesn't work because B and C are still on the wrong sides, right? If I flip it up, I'm like, oh, dang. So I'm going to reflect over line M. So at least now, like the long side's on top and the pointy's on the bottom. But it looks like that's still not enough because if I just flipped it, it would be like over here, right? And that would be A, B, and C. So it looks like I need to flip it again. I need to do another reflection to get it over onto this side, right? So looks like I need another reflection. We'll call that line, I don't know, T. So we're going to reflect over line M, then reflect over line T. So I need to reflect it up and then reflect it over, and that would give me this little guy here. If you wanted to, I suppose you also could have said, if you put a little point here, you could have called that like point E. You could have said it was a rotation around E of 180 degrees. You could have said that too. There's a couple of ways you could have approached this. I saw reflection and reflection. Maybe you saw rotation. That's okay. Works for you. Question number 5. We're asked to complete the translation given the function. Oh, we did a bunch of these, right? We did a bunch of these. So it looks like that says an R. That should say a T, shouldn't it? There's a typo. That should say a T. Sorry, it says R. That should be a T. My bad. So I have T sub AB, PQRS. Now let's see what we've got here. I am translating it from A to B, so that means we're kind of going in this direction. It should be moving parallel. So I'm going to go ahead and I'm just going to start with Q because it's the easiest and the closest. I'm just going to take Q and I'm just going to be like, and I'm going to make a parallel line. Woo! I'm going to go ahead and use my compass and measure A to B. And then I'm just going to hop over here to Q and make a little mark. And if that's Q, this is now Q prime. If you would like, you can do that for all of these points, make a parallel line. Or if you're like, no, I got this now. I see how it's moved. And you know I'm not going to be too judgy about your artistry because we know I lack that skill. But I can see that's the upper right corner of my parallelogram, so fine. I'm going to make the upper right corner of my new parallelogram. Ooh, I'm not doing so good. It should be the same size and shape. We know I'm not a great artist. That's okay. So that's Q prime. That would be P prime, S prime, R prime. If you're like, Miss Scott, that's terrible. It should be more precise. You are welcome to make some more parallel lines through P, through R, through S, and go ahead and do it properly. That's okay. But as long as I can see you at least in one parallel line and you at least measured one of the points and then drew your rest of your figure from there, I'll probably be okay with that. But I should definitely see that parallel line. I should definitely see that little mark that shows me use your compass to measure AB and get the right distance going. So let's come on over here to number 6. We are doing a reflection. A reflection over line N of triangle ABC. Cool. Please remember that our lines need to be perpendicular to our center. So you know what, to make it easier, I'm going to turn my paper. I'm going to turn it like this. And I'm like, great, that's the center. Let's make some lines perpendicular to it. I'm going to make them way too long on purpose. You know how I do that. Cool. And now I can measure. Here's A, and it hits in the middle. Grab my compass. Ooh, I don't even know if my compass can measure that. It's so tiny. So A to the middle, which my compass can't quite do it. You can do it, baby. Poor little compass. It's like it's too close. We'll call that A prime. And then if I measure from C to my line of reflection, so stabby guy on C, pencil in the middle, and then I'm going to hop over and make a matching mark. And I'm like, cool. So I'm going to call that C prime. And then I'll do it again here with B, and it's got to hit the line and then come out the other side. So stabby guy on B. I'm going to adjust my pencil so it hits that center, and then hop over, make a little mark. And I should be able to see your marks, right? I should see that these parallel lines are perpendicular to my line of reflection. I should see that you're measuring and making those marks. You should be labeling your new points. And of course, I'm going to connect them up to make my triangle. That's pretty good. Of course, when I put my paper the right way again, it looks a little sideways, but it looks good. It's a pretty good reflection. I think my A prime is a little bit off, but that's because it was so tiny. My poor compass couldn't get that small. It's all right. All right, let's come down to the last one, the one that requires the most steps. Yeah, we're going to complete the rotation. So X is my center, and we're rotating 75 degrees. Now, because that's a 75 degrees, we know that's positive. So that means we're going to be rotating counterclockwise. In fact, I'm going to write it off to the side over here because I fear that's going to get in the way. So we're going to go counterclockwise since that's a positive 75 degrees. So that means this thing's going to get rotated. If I have that tied to the end of X, if I have my little R tied to the end of X, it's going to swing around this way, right? This is why you need the protractor. So first of all, I'm going to use the straight edge and I'm going to connect X to R. Again, I'm going to make it way too long so that it's easier to measure things with my protractor. That's just how it goes. I need it to swing this way. So I'm going to grab my protractor. The hole is going to go on my center of rotation. And I'm going to line it up with the line that I just drew. 75 degrees. I don't know how well you can see because my camera, there we go. So 75 degrees, I see 60, 70, 80. So 75 is going to be right about there. Now go ahead and make the other side of my angle. Now, of course, this is way too long. We know it's way too long. So I'm going to grab my compass and I'm going to measure X to R. So stabby guy on X, pencil side on R. And then I'm just going to come over and I'm going to make a little mark. Should be able to see that mark. And that's my new R prime. Yay. Great, but I got to move S as well. They're both in there, right? They're both getting transformed. Cool, so I'm going to grab my straight edge. I'm going to do all of this again for S. So X to S. I need it to be 75 degrees. So I'm going to put my center over my X, my center of rotation. I'm going to line up the side of my protractor. Woo, see how that lines up perfectly? And, oh, almost, there we go. With the line I just drew, we're going to line that right up there. And we said 75 degrees, 70, 60, 70, 80. Okay, so 75, right about there. I can see it's between 70 and 80. And I'm going to go ahead and connect X to that. Whoa, there we go. And again, way too long. It's way too long. I know it's way too long. So I'm going to use my compass. I'm going to grab the compass. I'm going to measure stabby side on X, my center. And I'm going to adjust my pencil so that it touches S. I'm just going to come out here, make a little mark. And there's the new guy, S prime. This is a line segment. I started out with a segment. I should end up with a segment. So I'm going to grab my straight edge and connect RS to S prime. Make that nice and dark and like obvious. Like that's the one. And you just rotated RS 75 degrees around X. Good job. As always, guys, I hope you found this helpful and I hope you found this useful. If you have questions or concerns, come talk to me. I'm around and I'll see you guys soon. Bye.